It's 9:45. We're going to have to get started. So if everybody could have a seat. Hey, Shirley. When I was looking at my presentations yesterday, I always prepare the day before, and Big Bang is longer, and there's 2 clips of animations that happen within our cells. And the thought is, if Darwin had been able to see inside the cells, he might have written a different book. But anyways, because of that, I don't want to be rushed. I'm going to move that to this afternoon because nothing follows us. In the morning, it's 10:45, I have to be out because the next speaker is walking through the door. So we're going to do black holes and exoplanets this morning, and then we'll do Big Bang just because it's, I don't want to rush it. And Big Bang has something very cool, but this is going to be great too. Okay, dear Lord, thank you so much for everyone here. Thank you for, again, your book of creation, Lord, in addition to your Bible, your scriptures that have been handed down and preserved and protected by you. So, Lord, we have a clear knowledge, but we have the ability and the accessibility to learn about you and to fall in love with you and to walk with you. And Lord, if this had all been left in man's hands, we would be nowhere and everywhere. So again, Lord, thank you so much that you did not want us to doubt or be confused so that we would know you. In your most precious name, amen. The speaker before here was just fantastic. He had about Bible studies, and anyways, I don't think he's here, but I want to tell him what a blessing that was. Okay. Mini Neptunes, super Earths, hot Jupiters, oh my! These are the planets that are going around different stars. Now, we used to not be sure that they were planets. We just knew something was dimming the star's light on a regular basis, but now, and I'll show you how we now see them, but we're seeing them. We can see their atmospheres, we can see the starlight, their star's light coming through their atmosphere. We can tell if they're rocky or gas giants. I'm going to tell you what each of these mean and why it has changed how we see our own solar system. And what's interesting is, Scripture does give us verses about beings on other planets. And all of these are too far away that we'll never get to them. But it has also changed how special and unique our solar system is. In other words, it's not just us and our planet, but our solar system is very unique. And I'm going to show that to you. Okay, so how they've changed the views of our solar systems. All right, so a mini Neptune is up to 10 times the mass of Earth, but the atmosphere is predominantly hydrogen and helium. And as we saw yesterday afternoon, the solar system, in other words, it's like our Neptune, mainly hydrogen and helium, but it's 10 times the mass of Earth. And a super Earth is up to 10 times the mass of Earth. Notice everything's in reference to us. But the atmosphere contains compounds similar to our Earth. And then a hot Jupiter is a gas giant with an orbit of 10 days or less. Now remember, Mercury went around the sun, it goes around the sun every 88 days. Think of how fast this is going if it's taking only 10 days to get around its star. That is fast. And that's why they call them hot Jupiter, because they don't make sense. There should be no gas on that planet. So again, just when we thought we had everything figured out, God says, okay, let them start discovering these other bodies going around stars, and it's going to show them, remind them, they still don't know. And without God, when God is not in the equation, we're going aimlessly. It's rabbit trails. All right. So here's the little guy. Kepler spacecraft was sent up in 2009 and studied 150,000 stars in the Lyra and Cygnus regions. They're very star-rich, and saw hundreds of exoplanets. In 2013, they repurposed. I love it. NASA's doing the recycling thing, and they renamed it K2, and that is what we're using to search for these exoplanets. They strengthened its equipment. Now, here's how they see it. This is actually before they bring in the Spitzer telescope. So see the star. The star is a big orange orb, and the planet is going along, and when it crosses in front of the star, you see a dip in the light of the star. We know that star's light. We can measure it and see it. And then there's a dip, and it's a pattern. It's like every 8 days, every 20 days. So there's something going around the star on a regular basis. And so that's how we see that. So we measure the depth of the dip in brightness, and that also tells us how large. So our planet Jupiter, when it goes in front of our sun, is a 1% dip. And Jupiter's huge. And our sun is average size, we believe. So when Jupiter, if we were on the outside watching Jupiter cross in front of our star, it would be a 1% dip. So they have that to go, okay, if this star is the same size as our sun, there's a 1% dip, okay, it's the size of Jupiter. A lot of these stars are bigger and smaller. This is amazing. So Brandon, this is where, not right now, let me set it up for them. Tell them what it is. Get ready though. Okay, astroseismology is a fairly new field, and it's exciting. We now have astroseismologists. They analyze a star's energy waves. So remember yesterday when we saw the sun, and remember I said that's a coronal mass ejection, you saw the fluctuating, the waves, all over the star. Well, when it does that, it sends vibrations to the center of the star, and as one astroseismologist said it, others see the stars, I hear an orchestra up there. They all make a different sound. Now, I told you Louis Giglio, he put a couple of pulsars, adjusted their sound and put it to music. I'm going to let you hear 16 stars, and you tell me what they sound like. Pretty cool, right? Thanks, Brandon. Did it sound like warming up for an orchestra? Yeah. That's 47 they call it 47 tuc, but it's Tucanae, Tucanae, or Tucanae. Anyways. And those are 16 pulsars, and pulsars are spinning stars, and we can photograph how fast they're spinning. And when we're looking at deep space, we'll look at a few of those pulsars. But anyways, there's 16 of them in this particular star cluster, and that's the sound they make because we pick up the radio signals from them, and that's the sound they make, and they each make something different. But isn't that beautiful? So I get how he hears the orchestra, so I wanted you to hear that. So this is where they are analyzing, and they see these vibrations, and because of this, and I wish I had the quote, because of this, they're going to have to revisit their theories of star formation because the mass isn't what they expected. If there was a Big Bang, if stars evolved, it should be like this, and it's not. Because of these vibrations going through, we can tell the interior of the star, and it's not what we thought. Again, you put God's not in it, we're not going to get it. So praise the Lord. All right, so then exoplanets are verified by ground-based telescopes. There's your twin scopes of the Keck telescope, which is in Hawaii, and that uses high-resolution spectrometers, as well as the space telescope Spitzer, which sees in infrared, to directly measure atmospheres, temperatures, winds, etc. So we're now seeing them. It used to be that we just saw a nibble or a wobble on the star, but we can now see them. And there's I think we're well over 3,000 that have been confirmed. So very interesting. Now here's a few exoplanets. Now I'm going to show you a few that are the famous, and a while ago, not too long ago, this year, somebody said, oh, I heard they found a set of exoplanets that are like Earth, and they're habitable. Well, again, that's guessing. We actually don't know that, but I'm going to show that. That's the TRAPPIST group. All of these exoplanets, now, think of our solar system, and Mercury's the closest. All of these exoplanets are between Mars to the sun, they're only in the interior. They're the internal orbits, because we call that the Goldilocks zone. Not too hot, not too cold. We think if we're going to find a habitable planet, it's going to be near where we orbit our star. So here's Kepler 11. It has 6 mini Neptunes. Remember, so those are gas atmospheres, 2,000 light years from Earth. If they were in our solar system, 5 would orbit between Mercury and the sun. That's amazing. See, now when we look at our solar system, we saw the rocky planets were inside and the gas giants were way far away. And we assumed all the planets would be just like our solar system, and they're not. There's gas giants right up against the star. So now this is a planetary scientist. Now tell me what his favorite word is. This is what he said when he saw the Kepler 11 system. He said, it's amazing. Amazingly compact, amazingly flat, there's an amazingly large number of big planets orbiting close to their star. We did not know such systems could exist. We didn't. So again, it humbles us. So here's NASA's illustration of WASP-18b. So the star will be WASP, and then or WASP-18, and then they put letters. So A, B, C, those will be the planets or the bodies going around the sun. This is a hot Jupiter orbiting its star every 8.5 days. Wow, that is fast. I mean, here's 55 Cancri. Now this is a super Earth. It orbits its stars every 18 hours, always facing the same side. So that means one side is permanent day, the other side is permanent night. When they say tidally locked, that's what that means. The day side is 4,400 degrees Fahrenheit. The night side is 2,000. They think it's just lava, but that's a guess. Here's Gliese 667 system, has 3 suns. And I'm going to show you the orbits of 1,700 exoplanets. And it's going to kind of be dizzying, but you'll see there's very different ones, but especially when a planet is going around 3 stars. Here's this one. This is where they started talking about alien structures. I just call it KIC 84. It's a star in Cygnus, and what happened is, since 2015, as much as 20% of this star's light has been dimming in an irregular pattern for up to 4 days. So irregular, 20% of a star, I mean, that's huge. And they started talking about, wait, maybe the aliens built a huge structure and they're using their solar power from their star, and that's going in between us. And anyways, it turned out, they said it must be some comets that have broken up because it's too irregular. They kind of got put down for that. All right, so here's the HD 8066b. It has an eccentric orbit around a star. It passes close every 111 days, which is that's interesting because typically they're super close to the star. But when it goes across the star, you saw how fast it is? So here you see the body, the planet. So you see it, look on the left where it's dark, and as it goes around the star, and the star is at that, the cross point there, the temperatures go from 1,000 to 2,200 in 6 hours. So they're showing you that it gets super hot, and then it goes and cools off and goes back super hot. So that one's been very interesting. All right, here's the TRAPPIST-1 system. This is the one that made headline news because apparently we all want to believe there's a bunch of Earths out there that we want to go to. Spitzer telescope finds the largest group of Earth-sized habitable zone planets orbiting a single star. That's what the headline said. This system is 40 light years away. We don't travel at the speed of light. Planets orbit closer than Mercury orbits our sun. They're closer. And each may be tidally locked. Each may be permanent day, permanent night, super close to star. Why would we want to go there? And there you go. You've got B through H. And those, of course, the artists did the illustrations. That's not what they really look like. How have they influenced what we believe about our own solar system's foundation? Here's Sky Telescope. That's a magazine I get so I can keep up with what's happening. The traditional model of planet formation, which dates back to the 18th century, said the planets remain roughly where they form. But the discovery of 55 Cancri E, which is that super Earth, and other super Earths turned this theory on its head. There are mysteries, and here's scientists. It's a BBC documentary, Secrets of the Solar System. It was just made 2015. We've watched it a couple of times. If you want to see where scientists are admitting they've been wrong for decades, but they were waiting for a theory to replace it, and that's why our kids have been reading these formation theories that not even the scientists believe. This is it. There are mysteries when we look around the solar system where the theories don't match what we see. That was Dr. Hal Levison. And this is Marek Kukula. He's a British scientist. When we try to model the formation of the solar system on a computer, something doesn't quite add up. And they've been doing this for decades. It's really hard to get the model to make the planets in the places where we see them today. And again, they're putting in an evolutionary information into the computer, and the planets aren't. It doesn't make sense because God put them there. Okay, grand tack theory. So here is the new theory you're going to be hearing about. It's been around for a few years, but it takes some years to trickle down. It's probably going to be in science books if your kids are, depending on the school. I don't know. I went to private school, but it was a Catholic private school, so we had evolution in our books. Is it the same with Christian Adventist schools? I'm assuming they use creation, right? No? Pardon? Does anybody know? Oh, they do. Okay, good. Okay. I was like, I hope so. All right, grand tack theory. All right, and these are the problems it solves. Mars is too small. Don't you hate it when somebody says that? You're too short. You can't play basketball. Our moon is heavily cratered. Asteroid belt is made of both ice and rocky objects. It should be one or the other. Either they're all ice or they're all rocks. And Uranus and Neptune are too far from the sun. These have been the problems for decades. They have not made sense, and we've just stuck to our theories anyway. So this is the theory. After Jupiter formed into a planet, it migrated inward towards the sun, crossing the asteroid belt. As it moved through the disk, it absorbed material, and so it absorbed material, which then left a lack of building material, and that's why Mars was stunted. I hope it doesn't take it personally. Okay, and then Saturn formed and also migrated inward towards the sun, eventually joining Jupiter in its orbit. So they both start going around the sun. And this migration, these two giant planets are just creating chaos, and all this debris is being flung and it smacks into our moon. So that's why our moon has craters. I know, it sounds like a little fairy tale. Jupiter and Saturn then change direction like a tacking sailboat. That's why it's called the grand tack. They move away from the front sun, cross the asteroid belt, which knocks icy clumps towards the rocky objects that are already there, and that's why we still have rocks and ice together. And now this is Hal Levison, and he's like a big Santa Claus, as you can see. And he loves to get, well, here's how he words what happened, and then I'll translate for you. Jupiter and Saturn get close and tug on one another. As a result, Jupiter and Saturn get a little excited. And that's how he says it. They get a little excited. Uranus and Neptune feel that fight, feel that tension. As a result, their orbits just go nuts. He also uses the term kablooey. So what he meant was that as Jupiter and Saturn, of course, as their gravitational pull is making them go back and forth, it actually just sent, kind of ricocheted Uranus and Neptune into where they are now. And of course, we know that's not true. God placed them in a specific place, order, for a reason. All right, here's the guy that is behind the grand tack theory. He's the one that created that. Knowing that our own planet's moved around a lot in the past makes our solar system much more like our neighbors than we previously thought. We're not an outlier anymore. This is right. We want a king like the other nations. We want a solar system like the other solar systems. Isn't that something? Humans, it doesn't matter which century we live in, it's the same. We want to be like everybody else. Here's this one. I'm concerned about us being normal, because if we're not normal and there's something really special about the solar system, then life is probably rare. They don't want to think that our solar system is special. And it would also lead down the path is there a designer? So what does natural selection say about us? Our planet, and this is Carl Sagan, our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. I would think he would be depressed every day. And he wrote a book called The Pale Blue Dot, and this is a quote from that. Here's this is Jonathan Nichols. Now, he's a Juno mission scientist, and Juno's up at Jupiter. So first the sun formed 4.5 billion years ago, and then what was left over, Jupiter formed, and then what was left over, from that we formed. So we're leftovers of the leftovers. Like I said, I would like to see if atheists have more depression than Christians. Oh, Scott Bolton. He's the one that headed up the Juno mission. Our solar system is mainly 4 big planets and some debris. That's all we are, is debris. Wow. Okay, let's see what Scripture says about us. You establish the earth and it stands. That's it. Boom. Period. God's hands established the earth. He made it perfect for us. He put it where it's supposed to be. It is the third from the sun, exactly between the planets. There's a balance. It's beautiful, and it stands. Earth was made special. And God said, let us make mankind in our image, after our likeness. Humans are special. You know my sitting down and my rising up. You understand my thoughts from afar. You comprehend my path and my lying down. You are acquainted with all my ways. Such knowledge is too wonderful for me. It is high. I cannot attain it. It's so lofty. And God said, my ways are not your ways, my thoughts are not yours. David is admitting, I can't wrap my mind around how much you love me, that you watch me. Talk about if this was a reality, if our lives were a reality show, wouldn't it be boring? Oh, they're waking up now. They're over there eating breakfast. I mean, and he can't take his eyes off of us. Oh, and here David's admitting, I can't grasp it. It's just too high. Now, what does science say about it? So now we're going to look at science, and I'm going to let you tell me if our solar system is special. Now, I'm going to turn it on, but I want to do the still first to explain to you what you're seeing. Okay, so on the right is our solar system. The circles, you see how there's some dotted dashed lines? Okay, that's the orbit that Mercury would be. So we're pretending our solar system is the sun, and the exoplanets that are going around their stars, they're in the between Mercury and our sun. That's how close they are. The next line, there's two, that would be between Mercury and Venus. And then the last line would be Venus to Earth. Okay? Now all of these are going to move. These are 1,705 planets. The young man, he just graduated this year from the University of Washington. He's an astronomer now. He gave me permission to show this to you. They're so cute when they say, oh, you're showing it to churches. Oh, how nice. Say hi to everybody for me. So his name's Ethan Cruzy. Just like I said, super nice, very enthusiastic. Can't wait to discover something out there. But what you're going to see is, okay, so the circles are the orbits, and the inner circle would be the star. Now, when you first start seeing it, like I said, everything's going to be moving, then it's going to pan back. But look at some of them, you'll see, I can't point them out because I don't, where I am. Anyways, but you'll notice, look and see if you can find really weird orbits, okay? Get ready. Whoops. There we go. It's going to get big. There it is. Now look at some of the weird ones you'll see. Like you'll see a planet going around the star and another planet going around the outside. Is our solar system unique? Wow, is it? Now he's going to pan back. He looked at this, what we saw, and he had to make every one of these. It's called an orrery. It's a mechanical replica of solar system. Isn't that something? And look at our solar system, completely unique. That's our solar system. Well, our solar system is just the first 4 planets around the sun. See where it says solar system? Yeah, so that's Mars, Venus, Earth, and Mercury. And then these are the others, and it's all their planets that go around their stars as close from Mars in. No, Milky Way's a galaxy. Yeah, forget that. These are in different galaxies. Well, actually, most of these are in our galaxy. Yeah. But these are stars that have bodies going around them. But wasn't that amazing? So answer me. According to science, is our solar system unique? It was completely different. And you notice these super Earths, mini Neptunes? We don't have any of those in our solar system. They said, why is the most common body out there not going around our star? And that's why there's a theory about Planet X. That's going to kind of satisfy. Well, it must have migrated so far out we don't see it anymore. But I'm telling you, there's science saying we are unique, we are special. So, all right, now we're going to go to black holes. So, whoops. But I want to show that to you. Big Bang black holes. And we'll see Big Bangs. Here we go. Okay, whoops. Now this is going to get technical, but here's what you can do it. You're all smart. Here's the thing. When we hear from the scientists, it's intimidating. It sounds like they all believe the same thing, and man, it's proven. And in fact, Dawkins, the head of the New Atheists, they're a different kind of atheist, you can go to his blog, and he admits that, he'll actually put the notes of what they talked about in their atheist meeting, and he flies over from England to the American Atheist Association. So I read it, it was a few months ago, and he said, in America, you need to stop using the word theory with the word evolution. He said, so let's practice saying it's a fact that such and such evolved, and you're going to start hearing that more. And again, it's just their strategy. It doesn't make it real. Just because somebody says it, just because it's a scientist, doesn't make it real. I like what Mike Tucker said about we're not thinking critically. We see news with our eyes, but not our minds. We need to be analyzing it and questioning. Do the research. And I'm going to show you the redshift and black holes. You're going to see it's not what you've heard. There's a lot of debate and there's a lot of problems. Okay, definition. In physics, the reddening of light sent out by an object moving away from an observer. So the redshift suggests the universe is expanding and thus supports the Big Bang theory. The Big Bang is the evolution of the universe. The black holes are the evolution of stars. Natural selection is the evolution of life on planets. See, the Big Bang, they believe, established evolution everywhere. That's why if you chop off the legs of Big Bang, it ends evolution. It all depends on the Big Bang being true. And we're going to look. And again, I'm quoting atheists, evolutionists. It's them saying this. All right, so this light spectrum is from our sun. You see the black lines show where the sun's elements absorb light. And so this is a spectrum. Remember, we can fingerprint the stars. And here's from a distant star. And see how the black lines, there's more of them going to the red? That's what they call a red shift. Okay? This theory that they determine distance and velocity, the further away objects are, the faster their speed is believed by most scientists today, except for one of my favorite guys, Dr. Halton Arp. This is him in a good mood. He's an atheist evolutionary astrophysicist. Now, I'm going to show you his curriculum vitae, his resume. Very impressive. So when I quote him, the guy has a right to say something. There's over 100 galaxies named after him. You'll see the ARP 269. That's him. All right, bachelor's degree from Harvard in 1949, PhD from California Institute of Technology, both cum laude. Worked with Edwin Hubble as a professional astronomer. Staff astronomer, Mount Palomar and Wilson Observatories, 28 years. He was a staff astronomer. He had time on the telescope, and he would arrange and teach. He joined Max Planck Institute. Now, you have to be invited. You can't just apply and be hired. The Max Planck Institute is so prestigious, you have to be invited to teach there. He went there in Germany in 1983. He discovered quasars with extremely high redshifts, which means they're receding from us rapidly. They were physically connected to galaxies with low redshifts in the 1960s. He started questioning redshift, Big Bang, black holes in the 1960s, and we never heard about it. Because when he made public these observations that dispute redshift, on which the Big Bang theory is based, he wants these assumptions fundamentally re-examined. You know what they did? They took away his telescope time. And he was a staff astronomer at those observatories. They took away his telescope time, and they refused to publish his articles. Well, along came the internet. He's like, I'm going to make my own website. So he did. And here's his quotes. When presented with two possibilities, scientists tend to choose the wrong one. The stronger the evidence, the more attitudes harden. Science is failing to self-correct. We must understand why in order to fix it. And he wrote his book, Seeing Red. And of course, they were upset and they ostracized him. And that's why he moved to Germany. See, there is a lot of backbiting. There's competition for funding. You know, because if you have the next best thing, you're going to get the funding. And he wanted the evidence to lead to the theory, and he said they're starting with the theory and tweaking the evidence to match the theory. He's an atheist, he's an astrophysicist, and he's saying there's problems on the inside. So when somebody's really passionate about evolution and there's no loopholes, there's no problems, tell them they haven't done the research. I'm going to, when we look at the Big Bang, when I list problems, I'm listing the evolutionists admitting these are our problems. But I find, in fact, in my own family, they don't do that research. They're not looking these things up. All right, when seen through the eyes of Dr. Arp, redshifts relate to the age of stars, not distance or velocity. And this is what I love. He understands that mathematics is the language of nature. And he said, so the beautiful geometry of this particular cluster, that's why they're together. He's hinting that there's a purpose of how they're together. All right, here's another skeptic. He's from Germany, Christoph Wetterich, a theoretical physicist at University of Heidelberg, Germany. He's proposed another explanation, and he has proposed this. It's featured in Nature magazine. Is this the most prestigious publication you can have your article posted in, and it's now under peer review. So other astronomers are looking at this. If he's correct, the redshift goes away. If the redshift goes away, what happens to Big Bang? See, pray for these guys. Because God's still talking to them. Even though they might not believe, they're questioning. This is what he said. The light emitted by atoms is also governed by the mass of the atom's elementary particles, especially the electrons. So the matter in the electrons. So that's what's governing the light. So if an atom grows in mass, the light it emits will become more energetic, and the higher energies, higher frequencies, would be the blue part of the spectrum. And so if they're lighter, the frequencies would become red-shifted. He's saying it has to do with how much mass is in the electrons. It has nothing to do with velocity and distance. This will do away with the redshift. All right, so here's black holes. I just wanted to give that to you because they're all connected. Some of the greatest astronomical contributions have been made by amateurs, and many of the grossest misconceptions have come from experts. He was a Navy physicist and chief scientist for the Hobart Center. Here's Halton Arp. At this point, I believe we must look for salvation from the non-specialists, amateurs, and interdisciplinary thinkers. He's given up on scientists because after what they did to him for decades, and he died just a couple years ago, he said, you know what? We have to get out of the scientific world and have the people that are open-minded coming in, the amateurs coming in that are looking for where the evidence leads. He says, that's where we're going to find the truth. Now, this is coming from within their ranks. This is what Scripture says. Is not God in the height of heaven? The Lord has established his throne in heaven, and his kingdom rules over all. But will God indeed dwell on the earth? Behold, the heaven of heavens cannot contain you. Unto you I lift up my eyes, O you who dwell in the heavens. So, heavens, even the heavens are the Lord's. So the Lord's throne is in heaven. He rules from heaven. He dwells in heaven. Why would his pure and holy kingdom be surrounded by random destruction? Really, when people tell me black holes are everywhere, I'm thinking, so where's God? I mean, this is what's happening, because the controversy's here, right, on Earth. It's not the whole universe. Okay, so here's what we know about black holes, and I'm going to show you the problems. Black holes typically begin as an average, they also call it main sequence star, whose nuclear fuel runs out. They call it a stellar failure. Their center collapses, triggering an explosion that sends the star's outer gas shell off into space. This is called a supernova, so they've exploded. This is a Crab Nebula. It's absolutely gorgeous. Here's an illustration of a supernova ejecting and burning off its remaining energy. So once it burns off the remaining, the gravity will take over and a black hole will form in an instant. It just collapses. Whew. Okay, this is the theory. Now this is Tycho Brahe. He's a very colorful character from history. He was in a sword fight and lost his nose. So he put a gold, I think gold or silver nose. And he became the darling of society. Everyone wanted to invite him to their party because of that nose. So not that I recommend that to get attention, but it worked for him. Okay, so he observed a brilliant star in 1572 AD, and 16 months later, it became invisible. So he sees this bright star, becomes invisible. It must have, of course, exploded, right, and died. It's called Tycho's supernova, and after 440 years, now emits several billion times more X-rays than our own sun, more energy than hundreds of suns, as it expands at 5,600 miles per second. Does it sound dead? No. Here's what it looks like. It's invisible to us. We have to use an X-ray, Chandra is our X-ray telescope up there. It looks like hair, right? Kind of a bandana of hair. Anyways, this is what it looks like, but not to us, because we can't see it. And this is where it's right below Cassiopeia. But again, it's invisible to us. But it's growing. So let's look at some others. 28 years ago, a supernova was observed by the European Southern Observatory, which is in Chile, in the Tarantula Nebula, and I've got the arrow pointing to it. And this was this is the closest one that we could see with the naked eye, and it's closest to our planet. So the scientists were excited, going, we watched it explode, now we can watch it die. Great, this is great science. We're going to observe it dying. SN stands for supernova. Supernova, it happened in 1987, and A means it was the first one to happen in 1987. I'm breaking the code for you. But in 2011, Hubble observed debris from this supernova. It reached a transition point. The fading was reversed as a new power took over. It reversed, and now it has increased in brightness, and its central star is expanding. Oops. Bottom line, astronomers at the International Center, because now they got to call in the experts, so they had them do research leading to high-resolution image of this supernova to find out what happened. Why isn't it gone? Their work suggests there's not even a black hole at the center of the supernova remnant. So what is going on? And then there's T. Pyxidus. Astronomers acquire new information by focusing Hubble on the recurrent nova T. Pyxidus, which erupts every 20 years. This thing is exploding every 20 years. And then it dims, and then it comes back. So I'm thinking stars are, when you think of a flower, it blooms and then closes. I mean, there might be phases or seasons within the stars. And of course, we always default to, it's exploded and dead. And now it's going to suck all the other stars around it, and they're going to be dead. Like, we're so morbid, right? Back to the drawing board. Now, this is Hubble site. Back to the drawing board. This new evidence suggests astronomers may have to rewrite their theory of nova eruptions and accompanying debris. That's rewrite the theory of black holes. And this was in 1997, so I'm going to show you the rewrite. White dwarfs in a relationship. One companion grows larger, smaller steals from a larger. Added mass causes nuclear reaction. So if the added mass passes a certain tipping point, it explodes as what they call a type 1a supernova. And type 1a supernova have actually been used. Well, I'm getting ahead of myself. So here's an example of a type 1a supernova remnant, except something is missing. So you see this circle of beautiful gas, and there's, translucent in the middle. Where's the other star? At the center of the supernova remnant should be the companion star to the star that blew up. Identifying this star is important to understanding just how type 1a supernova detonate, which in turn is the key to calibrating the entire nature of our universe. The entire nature of our universe, they're saying, depends on if we get this right, if we understand stars evolving. I think knowing God is what we need to know for the understanding the nature of the universe. But that's how much is weighing on this. So over the past 14 years, this is an Israeli scientist, and listen to what he says. We use type 1a supernovae to determine the universe is actually accelerating. So he's saying to support the Big Bang, we're using these supernovae to support that. But the nature of these events is poorly understood, and there is a fierce debate about how these explosions ignite. They're debating. It's not a for sure, and yet by the time it gets down to the general public, I've actually seen in the newspaper, Hubble finds another black hole. Like, it's a fact. Saw it. It's there. Up to this point, we've learned dying stars without fuel emit more energy centuries after they die. A missing companion star raises doubts about a critical theory on which rests the entire nature of our universe. What other theories are there about black holes? Black holes are detected by X-rays. They emit as they pull nearby stars into their hole. We've all heard that, right? That's how they work. Well, in reality, not this supernova. The stunning lack of X-rays from supernova 2014J will require astronomers to explore other models to explain what triggers these cosmic explosions. This is an astronomer writing on NASA. They post their article saying, we need to look somewhere else. This is not making sense. There is no X-rays, and they're supposed to be. See? It's not what we think. Here's a theory illustration on how a black hole on the left is pulling in a nearby star's gas shell. X-rays on chart below. But reality, our own Milky Way's black hole, which is called Sagittarius A, or Sag-A for short, was caught ingesting something else, and Nancy's going to tell us. And this is in 2012. I'm going to show you how this theory was turned over in 2 years. Scientists have determined the black hole could be feasting hungrily on asteroids that come too close and vaporizing them, creating the flares. Basically, the black hole in our galaxy is totally rude, is eating asteroids and belching X-ray gas. Okay. This was what happened, 2014. We saw, it's called G2. See that yellow, the yellow blob, then dark orange and blue? We started seeing this thing. We don't know what it was. We didn't know if it was a cloud, but it was moving towards the center of our galaxy. We said, finally, we're going to see the black hole in our galaxy tear it apart. 3 astronomy groups from 2 countries waited because they were like, finally, we're going to see the black hole in our own galaxy. Reality. The initial prediction that the G2, the blob, would smear out as it approached the black hole, and some of the matter would fall in. The galactic fireworks never appeared. There's not a black hole there. And we've all heard, in fact, Time Magazine had an article on how the universe is going to end, and it had black holes have basically ingested everything, and so they called it digital intelligence is floating around somewhere, whatever that means. And they said the universe will once again be a cold, lonely place. And I'm like, if you only knew. It's going to be bright, light, colorful, love, joy. It's going to be wonderful. Here's another theory. The surrounding debris of a black hole is an event horizon and believed to be the point of no return. Not even light can escape. Reality, this jet of light extends 5,000 light years from M87 center, where a supermassive black hole is supposed to be. And it keeps changing. Look at this, 1999, 2002, 2006. This one has 2 jets of light going in opposite directions. So, they always have a rewrite. Astrophysicists now believe after a star dies and collapses, ultimately forming a black hole, it continues to cause havoc. This is a tweaking of the theory. The baby black hole devours material at the same time spewing it back out, a process that is revealed in the outbursts of light. And then what does Dr. Arp have to say about black holes? And I'm going to tell you what Einstein has to say. Stephen Hawking, who has been the advocate for black holes for 40 years, wait till you hear what he has to say. Here's what Dr. Arp says. When X-ray telescopes found strong X-ray sources in galaxies, they said, aha, this is too strong to be an X-ray star. It must be a black hole in orbit around a star. So he's saying what scientists believe. The X-rays meant a black hole. Strangely, when these objects were seen optically, no one took spectra in order to see what they actually were. Finally, the authors showed the spectra of 2 of them to be that of high redshift quasars. They were quasars creating the X-rays, not black holes. And remember, black holes that's made up. I mean, that's a big theory. It says it's quasars, and nobody ever looked. See, that's why he's so great. He's like, well, let's study it out. He says, bye-bye Big Bang. This is on his website. All right, now you've heard these. The gravitational waves detected from space believed to be echoes from the Big Bang. This was in March 2014. This is in Antarctica. Less than a year later, nope, just dust. All that money, putting that scope, or it was collector of gravitational waves, all that putting in Antarctica, it was just dust. Here's another one, LIGO. Now these LIGO, this is 1,000 scientists using $1 billion. They wanted to listen to black holes from a long time ago. So they have 2 of them. One's in Louisiana, and I think one's in our state, Washington. They find evidence for 2 merging black holes 1.3 billion years ago by detecting a chirp of gravitational waves on September 14th, 2015. All right? And from 2002 to 2012, this actually failed. So then they put in all this new money and updated things so where they could hear trucks rolling by hundreds of miles away on a freeway. It's that sensitive. And it was so interesting. It failed. They put in new money, and like 2 days later, success. So I'll tell you what one scientist thinks about it. All right, here's a guy from Ireland. A binary system with 2 black holes of around 30 solar mass is puzzling. Astronomers will be asking, how can massive stars end their lives so big, and how can they create black holes so massive? He's questioning it. It doesn't make sense. This guy from Australia, some would call this more a theory of funding, not gravitational waves, but gravy waves. The more sensational the headlines, the more news media attention and funding potential. If the LIGO signals were caused by gravitational disturbance, both detectors should have received it at the same instant. They did not, so the signal has nothing to do with gravity. So see, it's not what we're being told. So what do the stars show us? The Eta Carinae star, seen in the southern hemisphere, it increased in brightness until 1843, which was believed to be its supernova event. It was believed to have died, 1843. That star's over with. It dimmed until it became invisible for 40 years. In 1998, it began to brighten, and by 2007, it's now one of the most luminous stars in our galaxy. Due to its continued increase in brightness in 2009, the star's explosion in 1843 was relabeled an imposter event. More stars have now been declared imposters, like they're purposely trying to fool us. Here's the star that should not exist. Okay, so to explain this, imagine we have oranges and apples and we explode both of them. So now there's pieces of oranges and apples on the floor. And let's pretend that new oranges and apples new fruit can form from the pieces that are on the floor. So there'll be some that they'll have mixes, right? Some will be part orange, some will be more orange than apple, some will be more apple than orange. That's what this theory says is with the Big Bang, the first stars would have only had the light elements, hydrogen, helium only. And then, so when they exploded, now they've created a soup. And apparently in the soup, then some evolution began, and so now lithium is out there. And so they start getting heavier metals. So each generation of stars being built up by the exploded stars will have different metals in them. And metals anything higher than, heavier than helium. But what they found is those first generation stars, again, according to Big Bang, are still out there. Well, how are they out there? I mean, if the Big Bang is true, there shouldn't be. Our star is our sun should be at least second or third generation. Again, God's like, take a look. So here it is. A widely accepted theory predicts stars like this with low mass and low quantities of metals should not exist. Researchers point out, now they're going to call it a name, this freakish star is probably not unique. We have identified several more candidate stars that might have metal levels similar to or even lower. It means we may have to revisit the star formation models. A lot of redoing. So what did the experts say? Here's Einstein. In 1939, he published a paper arguing against black holes. In a nutshell, black holes do not exist because there is an upper limitation on the gravitational energy that a mass can produce, and since that energy is needed to recreate a black hole is greater than the equivalent energy of the mass, a black hole will never form. Einstein. Stephen Hawking, the one that's been the advocate for black holes, he has degrees in applied mathematics, theoretical physics, and cosmology, and you know he's a rare form of ALS. I admire. The guy made sure he lived a life. He is best known for creating the modern theory of black holes. Guess what he said? He told NASA, you can stop looking for black holes, now you can look for gray holes. Just as Hawking's original theory was not definitive, so too is this new theory on an apparent horizon. Now he's saying, we just thought it looked like light couldn't escape. We just thought it looked like gravity imploded and became the heaviest. But now it's all apparent, and so go for gray holes. So in other words, kind of a half black hole. So he's saying, we really don't know. And that's him. And here's Stephen Hawking. The defining characteristics of a black hole may have to give if the two pillars of modern physics, general relativity, which has to do with gravity, and quantum theory, are both correct. If the pillars of physics is correct, black holes don't make sense. By Stephen Hawking. So that's what I'm saying, is we don't have to, worry or think, I don't have proof, but they just have to do the research. They're not doing it. It's out there. So what does Scripture say about black holes? I stretched out the heavens with my hands, and I have set all their host in order. You alone are the Lord. You have made heaven, the heaven of heavens with all your hosts, and you preserve them all. His, King David's seed, who is Christ, right? Jesus is the seed of David, shall endure forever, and his throne as the sun before me. Our sun's not going to explode. And of course, the theory is it's going to explode and take out all the planets. Lift up your eyes on high and behold who has created these things, who brings out their host by number. He calls them all by name. This doesn't sound like random balls of gas out there that can explode and go away and it doesn't matter. By the greatness of his might, not one is missing. A black hole is a dead star that's missing, and then it starts destroying all the other stars. He counts the number of stars. He calls them all by name. His name shall endure forever. His name, not only the seed of David, Jesus will endure as long as the sun, but his name shall continue as long as the sun. That sun's not going anywhere. According to the inspired ancients, stars don't fail, explode, collapse, or leave behind a swath of destruction as they devour entire galaxies. They are named, numbered, assigned an orbit among billions of other unique stars, and preserved forever. No rewrites, no imposters, no problems. And that's the black holes. Did that help? Does that help when you... Yeah, I just want you to know there's a lot of doubt within their ranks. And I'm glad for that. To me, those are the humble ones. They're saying, you know what, something's not right. And I applaud them because, they don't have to write that. And they do. So any questions? We've got some time. Okay, we'll have a closing prayer. And this afternoon will be Big Bang. Dear Lord, if you have put this much into stars, and Lord, they obey you. They have been given an orbit and they obey you, Lord. And then you make us how much more unique and special and loved we are. You said we are more important than sparrows and the lilies of the field and also the stars. You have named the stars, and Lord, you've promised you will give us a new name when we get to heaven. We are just so unique in your eyes, Lord. And again, once more, when we see how unique the stars are to you, that you even named them, that shows a personal attachment, a personal awareness of that star. The intellect that would know that, Lord. You are the divine intellect of the universe, and you know us, you see us, you remember everything about us. Lord, it's just like David. How can we grasp it? We just have to accept it and say yes to you every day. And we thank you. Praise your name, Lord. Amen.
Okay.